So my name is Elaine Ng. I work as a postdoc at Elaine Ng University. My work duties include research work in the areas of cognition and hearing, and teaching as well. The main goal of my PhD thesis was to look at the relationship between cognition and hearing. One of my studies was to look at the potential cognitive benefit of a noise reduction algorithm. And currently, the test was focusing on speech understanding and not so much about measuring the cognitive benefit of hearing aid use. So I developed a test which is called the Sentence Final Word Identification and Recall Test, which was aimed to measure the cognitive benefit of noise reduction algorithm. Listening in complex speech environment, for instance, having competing speech information in the background, that will further impairs the memory performance because competing speech contains linguistic information that interferes with the target speech. So that would acquire more resources in speech understanding that will leave even less resources in doing the memory task. The hypothesis of the study was that when noise reduction was on, it will be easier to understand speech, and that will make speech understanding less effortful. That will leave more resources in remembering the target speech. So that would increase the memory performance. So first thing will be the audiogram. So I have to check if they have bilateral, symmetrical, moderate sensorineural hearing loss. The inclusion criteria is they have to have symmetrical hearing loss. After the audiogram, we move on to the cognitive tests. First, we estimate the signal-to-noise ratio that estimates the 95% of speech understanding in a 4-talker babble noise. And then after obtaining that SNR, we run this sentence final word identification and recall test, which is commonly referred to as SWIR test. In the SWIR test, the participants had to first repeat the final word of each sentence, and then there are 7 sentences in the list. So after 7 sentences, the participants had to recall all the final words again. This is the result. The y-axis represents the recall performance in percentage. The x-axis represents the list position. So primacy here refers to the first few items of a list. Asymptote is the middle items. The third, the fourth, and the fifth item, and then recency are the 6th and the 7th item of the list. And the orange line represents the recall performance when noise reduction was off, and the gray line was when the noise reduction was on. So here we see there is an effect of noise reduction, that noise reduction improved the memory performance. Here we can see there is the benefit was across all positions, and in particular, the performance was the best in the first few items of the list. So a greater improvement in the primacy position, that means the first 2 words in the list, could indicate that noise reduction enhances the encoding of words into longer-term storage.